Dr. Steve Case. I teach astronomy at Olivet Nazarene University, which is in Kankakee, Illinois. And I'm also the director of the campus planetarium. So unfortunately, you guys can't come to the planetarium, so I'm going to be bringing the planetarium to you guys. I'm going to talk a little bit about the night sky, some of the things that we can see in the sky, and then we're going to use that to talk about stars, because I know you guys have been learning about stars, and then take a quick tour of the galaxy and then the universe. And last time when I was here on Tuesday, the other classes had some really good questions. So hopefully we'll have some time at the end where you guys can ask me some questions and we can talk a little like that as well. So everyone can hear me? Is that, you guys just want to give a thumbs up if you guys can hear me? All right, okay, cool. I'll just say a little bit about myself. I grew up as a kid going to the planetarium in my hometown, and I'll tell you guys a little bit about what a planetarium is in just a minute. But I loved seeing the night sky in the planetarium. I thought it was amazing that we could go basically into space any time of day. And so I grew up wanting to work in a planetarium. So I went to school, I learned a lot about astronomy, and that's what I get to do now. I get to run a planetarium. So I'll tell you a little bit about what that is, what a planetarium is. You guys should probably see on your screen, you've got a picture of this goofy looking building with kind of like a weird dome shaped ceiling. Can you guys see that? So that is the planetarium. And for those of you who haven't been in a planetarium before, what happens is you come inside, and the reason that the roof looks so funny like that is because inside it's a giant dome. And I'll actually try to show you guys that as well. So I'm going to move my camera just a little bit and give you guys a little quick tour of my planetarium. So there's not a whole lot to see. It's kind of empty, but we've got the seats on either side that you guys would normally be sitting in. And then we've got this thing in the very middle of the room. That's our projector. But then if you look at the ceiling, it's just this big white dome over your head. And if you were in my planetarium, you'd be sitting in here in these seats, and you'd look way back up over your head, and you would see the things that I'm going to show you on your computer screen. So a planetarium is a place where we can project the night sky. We can look at the stars inside this building. And because, again, because you can't be here right now, I am going to project the planetarium onto your computer screen. So that's what we're going to do now. I'll go back to sharing my screen with you guys. And you're going to see this big black circle on your screen. That is our planetarium dome. And I'll turn the sky on for us. So what you need to think about here is you've got this big circle. And this is basically the dome above our head in the planetarium. So on your computer screen, you can think of the bottom as though you were looking due south. If you were sitting in these chairs, looking at the dome in front of you. Up at the top of your screen, that would be like if you were craning your neck to look back behind you to the north, and then to the left is east, and to the right is west. And in fact, I'll go ahead and I'll turn on some little letters on our sky so we can see the directions that we are looking. So you could imagine that you were just laying flat on your back, looking up at the sky, and this circle was the circle of sky above your head, like this horizon making a big circle around you. So if you were looking right in the middle of your screen, it's like you're looking directly over your head. And you guys could probably see way down here in the bottom of the screen, down in the southwest, we've got this white little dot. That's the sun. Because right now we're looking at a daytime sky. Now there's not a whole lot of interesting things to see during the day in the sky, unless you're looking at clouds or things like that. So we're going to go ahead and we're going to move time forward. And we are going to advance to set the sky for what it's going to look like tonight. So we've got the sun starting to set low in the western sky. And we're going to see some of the first stars come out. But I'm going to pause it right here because I want to show you guys a couple things we can see in the sky before the sky is even completely dark. I want to show you guys a couple things. You could go home tonight, and if it's clear tonight, you can find these in the night sky. So the first thing I want to show you is if you look way down at the bottom of your screen, you've got these two dots right here. you've got Jupiter and Saturn, the two planets right next to each other in the southern sky. So let's go ahead and we'll turn those labels on so we can keep track of those, Saturn and Jupiter. And Saturn and Jupiter are two of the planets that we can see with our naked eye. You don't even need a telescope. If you go outside and you look in the southern sky tonight, you're going to have these two bright points near each other. And in fact, if you watch them for the next month, all the way into about Christmas time, every night they're going to get a little bit closer together. They're actually moving toward a conjunction when they're right next to each other in the sky. They're actually going to be closer together in the sky on December 21st than they have been ever in the past 400 years. So that's going to be something really cool to look at. The other thing that we can see in the sky tonight is you've got this dot that looks kind of reddish in color over here in the east, rising as the sun goes down. That's the planet Mars. So we actually have a chance to see three of our naked eye planets tonight in the sky: Jupiter, Saturn, and Mars. On a clear night, without a telescope or anything, you can find these just as the sky is starting to get dark. Let's go ahead and roll time forward a little bit more, and let's get that sky all the way dark and the stars to come out. There we go. All right. So I want to show you guys just a couple constellations and talk a little bit about what the constellations are. And then I'm going to end by showing you my favorite constellation. We're going to use that to learn a little bit about stars. And from there, we're going to go out into space and actually travel to some stars and take a look at them. So normally when I start talking about the sky this time of year, I have everybody look for a giant triangle, a triangle of bright stars nearly overhead, almost directly overhead as the sun goes down. And this triangle is right overhead in the summertime, so we call it the summer triangle. I'm going to draw it on your screens for you. It's this collection of 1, 2, 3 bright stars that makes a big triangle with the Milky Way galaxy going right through it. Now, the nice thing about the planetarium is we can show the night sky as it would look on a really dark, really clear night. So on a dark, clear night, you'd be able to see these 3 stars pretty easily. And each one of these stars is part of a separate constellation. So we've got a constellation called Lyra, tiny little constellation up here. We've got another one called Aquila down in the south. And we have another constellation called Cygnus. So each one of these constellations, one of the stars in them make up one of those points of that triangle I just showed you. And I'm going to zoom in a little bit on these constellations because this is a good way to illustrate what I wanted to say about how constellations work. So constellations are collections of stars in the sky. And you've maybe seen them like this before, where they're kind of like connect the dots with some of the brightest stars. Classically, though, constellations were pictures, things that people imagine in the sky. So the tiny little constellation of Lyra, people maybe imagine looking a little bit like a harp or a lyre. The constellation of Cygnus, the one that kind of looks like a cross going down the Milky Way, people imagine looks sort of like a swan. So that's how it got its name, Cygnus the swan. And then the Aquila, kind of with the wings on either side, maybe people thought look a little bit like an eagle, Aquila the eagle, carrying Ganymede through the sky there. So all of the constellations were originally named for different Greek and Roman myths. And if you've ever read the Percy Jackson books, you probably know a lot more constellations than you even realize. But the way that astronomers use constellations today is a little bit different. Astronomers don't care quite as much about the imaginary pictures. They're more interested in using constellations as boundaries. Or I tell my students to think about constellations as zip codes in the night sky. So if you're talking about what you can see in the night sky and where you might find different objects, if an astronomer says, oh, there's this new comet that we just discovered and it's in the constellation Cygnus the Swan, what they mean is it's somewhere in this outlined region of the sky. So astronomers have divided the sky up into 88 of these regions, and those are the 88 constellations. So again, constellations are kind of connect the dot figures based on figures from mythology, but the reason that we would still use them today has to do with it helps us find our way around the night sky. Okay, So I want to show you just a couple more constellations. And don't worry, there's not going to be a quiz. As far as I know, your teachers are not going to test you on these constellations. So you don't have to memorize all of these. But I want to show you guys a constellation that you probably already know. If you look way up toward the top of your screen, up near that N at the top, you're going to see a constellation that at least part of it might look familiar to you. Anybody recognize this part of this constellation up here? Anybody know that one? Yeah.
Leo the lion.
Oh, I'm sorry. Go ahead. Say it again.
Leo the lion.
Ooh, that's a good guess. It's not Leo the lion. That one is Ursa Major, the big bear. But the part that most of us know, we know this portion of it as the Big Dipper. So that's the Big Dipper. The Big Dipper's up there in the northern sky, and you can always find it somewhere in the north. And we use the Big Dipper, this part of the Big Bear, to draw a line to another star that maybe you guys have heard of, Polaris, or the North Star. So we use these two stars in the bowl. We call them the pointer stars, because if you draw a line through those stars to the north, you run right into this star, Polaris, or the North Star. Now, I want you to do this. I want you to keep your eye on this star, Polaris, and I'm going to move time forward. So I'm going to let us watch how the sky changes over the course of the night. So I want you to notice what's happening, but I also want you to watch that one star that I just pointed out, the North Star, okay? You guys ready? All right, we're gonna roll time forward, and we're going to let the night go by. So you probably notice most of the stars look like they're rising in the east, moving across the sky, and setting in the west, except if you're keeping your eye on the North Star, what you might be noticing is that that one star isn't moving at all. All the rest of the stars appear to revolve around the North Star. So it's like the entire sky is spinning, but it's spinning around this one point. And that point happens to be close to Polaris, or the North Star. So what's happening here is the Earth is rotating. It's rotating on its axis, and it's making it look like the sky is moving. But the Earth rotates around the North Pole, and this one spot in the sky right above the North Pole where the North Star is doesn't appear to move. It makes it look like the rest of the sky revolves around that one point. So that's why the North Star is important. It helps us find the way north, and we know as the rest of the sky moves every night, the North Star is always going to stay in the same place. But I brought the sky around because I wanted to show you our last constellation, because this is how we're going to use to go into space and learn some things about the stars. So let's turn this constellation on. It's sort of this hourglass constellation here high in the southern part of the sky. Now, right now, you have to wait pretty late. You have to stay up pretty late if you want to see this constellation. But as the winter goes on, it's going to get higher in our sky every night until around about Christmas time, you'll be able to see it rising in the early evening. And this constellation is Orion the Hunter. So it's kind of this hourglass figure. You've got the 2 feet of Orion here. You've got Orion's belt. You've got Orion's shoulders. So that's the constellation Orion. Now, what I want to do is I want to show you 3 things in Orion. And then we're going to travel to these points in space and talk a little bit about them. So all of the stars that we see in the sky are stars, right? They're all suns. They're all like our sun, the star. But we're seeing them at a huge distance. So we want to travel out to those stars and actually learn a little bit about them. So the first star that I'm going to show you guys is this star right in the shoulder of Orion. And it has a really funny name. That is the star Betelgeuse. So I'm going to turn Betelgeuse's label on there. It's kind of small, but that's Betelgeuse right in Orion's armpit. And then the other star that I want to show you is this star opposite Betelgeuse right down in Orion's foot. And that star is called Rigel. Now, if you look at Orion and you can find these 2 stars, what you're looking at is you're looking at a really, really old star, and you're looking at a really, really young star. And right between the 2, just below Orion's belt, the center of Orion's sword, there's this faint, fuzzy patch of light we're going to visit as well. That's the Orion Nebula. So we'll start with Betelgeuse first. So let's change our point of view and let's leave the Earth's surface and actually travel out into space and leave our solar system behind and go to this star, Betelgeuse. So we're taking off from the Earth right now. There's the night side of the Earth. We can see some light from some cities there, the glow from the nighttime portion of the globe. And we're going to orient ourselves, spin our spaceship around, and prepare to head toward Betelgeuse. Now, I should say a couple things about this trip. Betelgeuse is hundreds of light years away. So if we were traveling, oh, there goes the sun, there goes the planets. If we were traveling at the speed of light, it would take us hundreds of years to get to Betelgeuse. But we're not, we're cheating. We're going to travel a lot faster than that. So here we are at Betelgeuse. So Betelgeuse is a star. It's the brightest star in Orion, like I just showed you guys, and we saw what it looked like from our sky. But if we were to actually travel to Betelgeuse, we would see it's like the sun. It's a lot bigger than our sun. It's actually a red giant star. So Betelgeuse is a really old star. It's a star near the end of its life. It's a bloated, big red giant. It's getting ready to go supernova. We're not quite sure when. And it's a cool star. And what that means is its surface temperature is low, so it has this sort of orangey yellow color. Now, you see these red lines that we're swinging around past? Those are the constellations that we saw in our own sky. And if we were actually to travel hundreds of light years to Betelgeuse, those constellations would start to look a whole lot different. And in fact, if we were to try to find the sun from Betelgeuse, I'm not even sure if we could find it. Let me turn on the label of the sun and see where it is. Okay, it's way out here. And I don't even know if we could see it with our naked eye. So from the distance of Betelgeuse, our sun actually is just going to look like a dim star. Let's do this one more time. Let's actually travel to Rigel as well. And let's take a look at what Rigel looks like. So we're going to leave Betelgeuse. So long, Betelgeuse. And we're going to swing around and travel to another several light years distance to Rigel. Now, Rigel's a sun as well. If we got close to it, we would see it's a big, fiery, gaseous object like Betelgeuse, but you notice it's different in color. Rigel is a really young star. It's a really hot, young giant star. So it's still burning hot and bright. And one of the things that's different about different stars, they vary in their mass. Some are big, some are small. They vary in their temperature. Some are hot, some are cool. And that temperature variation makes them vary in color. So they're different colors. So a really hot star looks more blue-white, like Rigel. A cooler star looks kind of orangish red. A star that's right in the middle, like our sun, looks sort of a bright yellowish color. So Rigel is a young, hot, bright star. And again, if we look at Rigel and we try to swing around and see if we can find the sun, Betelgeuse, again, looks just like a star again because we're so far away. And the sun is, again, probably too dim to see. We got this nice band of the Milky Way stretching behind. We'll talk about that in just a moment. So we're in Orion, the constellation. We visited Betelgeuse, a really young star. I'm sorry, a really old star. And then Rigel, a really young star. But now we're actually going to go see some baby stars. Remember, I showed you three things in Orion. I showed you Betelgeuse in the shoulder, Rigel in the foot, and then between them, I pointed out this sort of faint glow that was called the Orion Nebula. Now, a nebula is a cloud of gas and dust in space. And the Orion Nebula is one of these nebulas that we can see in the constellation Orion. And what's happening in the Orion Nebula, and here we are, this cloud of gas and dust at the very center of the Orion Nebula, where gravity is pulling this gas and this dust together, young stars are being born. So you can think about the Orion Nebula as like a stellar nursery. And in the center of that nebula, new stars are actually being born right now. And we can see this with our naked eye. We can see the Orion Nebula with our naked eye on winter nights from our place on the Earth. And again, from this distance now, Betelgeuse, Rigel, and the Sun all just look like tiny stars because we are so far away from them in our galaxy. All right. So when it comes to the stars, right, they're suns like our own sun. They're just so far away from us from our point of view on Earth, they just look like these tiny points. Now you're getting a little sense of the scale of our own galaxy right now. We're flying around to different points in our galaxy, and we're visiting things that are hundreds or even thousands of light years away. So that means if we were actually traveling there, it would take us hundreds or even thousands of years to get there. What I want to do now, though, before we ask some questions and things like that, I want to take us back to Earth, and I want to give us a little tour of our own solar system and talk about some of the things that are in our solar system. So let's head back to the surface of, actually, let's go back to our sun. We've looked at Betelgeuse and we've looked at Rigel. Now let's head back and let's take a look at our sun. And we can talk a little bit about our solar system and then go out to the very edge of the universe. All right, so here we are. We're back at our star, the sun. And I said it looks a little bit like Betelgeuse. It's a much smaller star than Betelgeuse, and it's this bright yellowish color because our sun is a middle-of-the-road star. Not too big, not too small, not too hot, not too cold. And our star, the sun, is of course the center of our solar system. So let's take a look at our solar system. If we were to go start at the sun and work our way outward, you guys tell me what the first planet is that we'd come to in our solar system from the sun? You guys can shout it out, it's all right. What's the first planet in our solar system?
Mercury.
Mercury, that's right, I heard it, okay.
Mercury.
So our first planet is Mercury. So that's this circle that I just put on here. That's Mercury going around the sun. So Mercury orbits the sun. And then let's turn on the next one. What comes after Mercury?
Venus.
Yes,
Venus.
yeah, very good.
Venus.
Okay. And then we have, what's the third planet?
Mars. Mars. Earth.
Oh, you
Earth.
that's right. We got to go to the Earth first. So we got the Earth and then Mars.
Earth.
Okay. So let's go back to
Earth.
Earth for a second. Let's fly to Earth. And let's talk a little bit about our own planet. Because we do have something orbiting around our own planet. In fact, we've got a lot of somethings orbiting around our own planet. So here we go. Now we're orbiting around the Earth. And if we move outward into space from the Earth, we come to our own natural satellite, the satellite that goes around us. Sometimes we see in the nighttime sky, sometimes we see it in the daytime sky. What orbits the Earth?
Moon.
The moon, that's right. Okay, so this white circle is the orbit of the moon. All right, we got the moon going around the Earth. We've got the Earth, the third planet around the sun. You guys already told me Mars comes next. All right, so let's put the orbit of Mars up there. And I want to stop us here for a second because we've got a good view of the inner portion of our solar system. Mercury, Venus, Earth, and Mars, all of the inner planets. Now, the inner planets are special because the inner planets are solid objects. They're rocky. They're all fairly similar to each other in their composition and what they're made out of. So for instance, if we were to travel to Mars, and if we were to visit the surface of Mars, which humans have never done, but we've sent lots of robots to Mars. We've sent several rovers. We have at least one rover right now active on the surface of Mars. We've got another one on the way. And if we were to travel to Mars, we could land on the surface and we could study things like volcanoes and craters and all sorts of geological features. There's a whole lot of stuff on the surface of Mars that's quite interesting to take a look at. But it's because the inner planets are solid. They have geology. They have rocky surfaces. Now that's very different from the outer planets where we're going to go next. So the inner planets are dense and rocky and have solid surfaces. The outer planets, not so much. All right, so if we were to continue to go outward from Mars, what planet would we come to next?
Jupiter.
Jupiter, that's right. Put the orbit of Jupiter out here. Jupiter is a lot farther than the sun. Yep, there you go. We got Jupiter.
Then it would go Venus.
And after Jupiter, what comes next?
Saturn.
Saturn, all right. Saturn is my favorite. So let's actually take a look at Saturn because that's a great example of how the outer planets are different from the inner planets. So let's fly to Saturn. Now the outer planets, the outer planets are not. The outer planets are gas giants and don't have any solid surfaces. So if we were to travel to Saturn, we would see the rings, we could study lots of different moons, but we couldn't do any geology on Saturn. We couldn't land on Saturn, there's no solid surface. We could study the clouds of Saturn and the storms in those clouds. We could study a lot of weather, but we couldn't do any geology. No geology on Jupiter or Saturn or the other outer planets. So that's one of the ways the outer planets are different from the inner planets. Okay, so you guys are taking me all the way to Saturn. What comes next?
Neptune.
Ooh, close. Uranus? Yep.
Uranus.
And then we all right. So here are all the major planets of the solar system, all the way from Mercury out to the orbit of Neptune. Now, last time the other class wanted to know about Pluto, right? Well, what about Pluto? Isn't Pluto a planet? Well, let's talk a little bit about Pluto, and then we'll go out to the rest of the galaxy. So Pluto was discovered in 1930.
Planet.
And when we discovered Pluto, we realized a couple things. We realized that A, it was really small, smaller than any of the other planets, and B, it had a wonky orbit. So you can see how the orbits of the other planets work. This green circle that I just put up here is the orbit of Pluto. Pluto's orbit is very tilted with respect to the rest of the solar system, which is a little bit odd, but we didn't think too much of it. Pluto's just a little weird, so we added it to our list of planets in the solar system. But then something really interesting happened. As our telescopes got better and better, we started finding more and more objects like Pluto out here at the edge of the solar system with Pluto. So now I've put all of the orbits of these trans-Neptunian objects on here. They've got funny names like Eris and Sedna and Huamea and Makemake. And these are all things that are about the same size of Pluto. So astronomers said, well, wait a minute. Are these all planets, or does it tell us that there's another class of objects in the solar system? And so it turns out Pluto orbits around here with a whole bunch of other stuff. And so the idea is that if you have something that's round like a planet, but that orbits with a bunch of other junk, we're going to consider it something different. We're going to consider it a dwarf planet. So Pluto, Eris, Makemake, Huamea, all of these now are considered dwarf planets. So they're still in the solar system. They're still important. They're just a different classification of objects. All right, let's keep moving out. So now we're getting out into our stellar neighborhood. We're beyond our solar system, and we're looking at some of the other stars that are near our star. And in fact, you notice the constellations are kind of getting stretched out and changing because the constellations are three-dimensional. They just have the shape they happen to have because that's how we see them from Earth. There, I just turned Orion on with Rigel and Betelgeuse. And you can see that Orion doesn't look anything like himself when we are actually way out into space because it just has that shape because of our perspective on the Earth. Now you see this band of light stretching across the sky that I mentioned I'd talk about in a little bit. All of the stars in our sky, all of the stars that we see are part of our galaxy, the Milky Way galaxy. And the Milky Way galaxy is that band that we see stretching across our sky because the Milky Way galaxy is flat. It's shaped like a plane. It's a big spiral disk. And we're inside that disk, and we see that stretching of the disk across our sky as a big glow. But if we were to keep zooming outward, we would see that our sun is just one star among something like 200 billion stars in our galaxy, the Milky Way galaxy. And in fact, you can see those little red lines. Those are the constellations. Those are the constellations. Those are some of the stars that we see in our sky. And they're just a tiny little sliver of the entire Milky Way galaxy. So here, this little area is the stars that we see in our sky. The galaxy itself is much, much larger. In fact, if you wanted to go all the way across the galaxy at the speed of light, it would take you something like 100,000 years just to go across our own galaxy, the Milky Way galaxy. So you have our planet, the Earth, as one planet in a little solar system going around our star, the sun. And then our star, the sun, is just one star in a system of 200 billion stars that we call our galaxy. And then if we wanted to go even further, some of you guys saw this as we were getting the show ready. Beyond our own solar system, in every direction that we look, we see other galaxies. So beyond our galaxy, rather, beyond the Milky Way, in every direction we look, we see other galaxies. And each one of these galaxies is a system of millions or even billions of stars. And there are trillions of these galaxies. So on the largest scale, our universe is made up of galaxies. And each one of these galaxies is made up of stars. And most of these stars have planetary systems similar to our solar system. All right, so we just went from the surface of the Earth all the way out to the edge of the visible universe. So let's do this. Let me pull you guys back up on my screen. I'm going to turn it back over to Mr. Gardner because, again, last time the class had some really good questions and we were able to dive into some of the stuff we talked about. So I'm going to turn it over to him so he can kind of proctor how we're going to do questions for the rest of our time together.
All right, guys. If anybody has a question that they want to ask Steve, and Steve, first of all, thank you for doing another great job of taking us on a trip around the galaxy. If you guys have any questions that you want to ask Steve, then please raise your hand in the Zoom. You can do this by clicking on the little tab at the bottom that says participants. And I will try and choose as many of you as we have time for. And yeah, we'll see what kind of good questions we have this time. Let's start with Kayla Gilson.
I was wondering if the world and the universe ends, will the stars still be there, or the constellations?
That's a really good question. So how long, one question is, you know, if something, whoa, I don't want to crash back into the sun, hold on. So if something that happens to us on Earth, for instance, are the constellations still going to be there in the sky? Let's do this. Let's take a look at that. Let's turn off our galaxies. Let's go back to the Earth's surface and let's get a look at the night sky again. Oh, we just crashed into Saturn. We'll reset ourselves and come back to our night sky. So a couple ways to answer that question. First of all, we can talk about how long the stars themselves are going to be around. And stars have lifetimes, just like people have lifetimes. They're born, and then they live, and then they die. But they have really, really long lifetimes. So as best we can tell, our sun, for instance, which is a middle-aged star, has been around for about 5 billion years and will probably be around for another about 5 billion years. So even after we're long gone on the Earth, the sun will still be going strong. But you also ask about constellations. So I want to show you something really cool with that. So let's turn on all of the constellations. So the constellations, remember, they're patterns of stars. So as long as we've been around, these patterns have stayed the same, but the stars themselves are actually moving. So if we were to come back millions of years later, the stars would probably not be in the same position. So I'm going to try to take us on a trip millions of years in the future. So hold on, we'll see if I can get it right. So here we go. Oh, that's what I was afraid of. I want to turn off the atmosphere so we don't hurt our eyes. Okay, let's try it now. So there goes the sun and all the planets across the sky. What do you guys see happening to the stars? Stars are actually moving as well. They just move really, really slowly. So we've just gone about 200,000 years into the future, and the constellations are getting really scrambled. So because all the stars are actually moving as well, if you were to go away from Earth for a couple million years and come back, you probably wouldn't be able to find the same constellations in the same places. So, good question. All right. Other questions?
Let's go over to Duncan.
How many rings does Saturn have?
Ooh, that's a good question as well. There's a couple different ways to answer that. And I won't take us back to Saturn because we were just there. But there are, I think something like 7 main rings that we can see and study from Earth. But if you get even closer, like we saw when we kind of flew through those rings are each made of millions and millions of different particles, tiny little bits of dust and rock. So each one of those rings is kind of like a system of millions of moons. But I think they're numbered by a letter. There's like the A ring, the B ring, the C ring, and I think there's about 7 of them that astronomers have identified. Good question. And Saturn's not the only planet that has rings in our solar system. So Jupiter has rings, and so does Uranus and Neptune, but they're really puny. They're not nearly as cool as Saturn.
Oh, I'm not.
All right, let's go over to Caden as well.
How many years have you owned that place?
Yeah, how many years have I worked at the planetarium? So I've been here for about 10 years. So I knew that I wanted to work at a planetarium. So when I went to college, I looked for colleges that had planetariums so I could learn how to run a planetarium as I was learning about astronomy. And there are not a huge number, but there are a lot of colleges that have planetariums. So I came here to Olivet, and this is where I did my degree. And I actually, as a student, learned in this planetarium several years ago. And then I went on to graduate school because I knew I wanted to be a college professor, and did a master's degree and then a PhD. And then a job actually opened up back here where I had started. So I've been here probably about 10 or 11 years now running this planetarium. Yep.
All right. Lily, your question.
So my question is, what is it? How many universes are there?
Yeah, that's a really good question. So Lily's question was, how many universes are there, right? We looked at stars, we looked at planetary systems, we looked at galaxies, but how many universes? So right now, the easiest way to say that is we don't know. Everything that we see in the sky is our universe, one universe. There are some scientists who think there might be other universes as well, but they're not observable. We don't have any way to measure them or investigate them. So right now it's just a theory. And as far as we can tell, just using our observations, there's just one universe, the one that we're in, that contains all of the galaxies and all of the stars and all of the planets. Yep.
Thank you.
Yeah, thank you. Good question.
Let's go to Clayton.
My question is, how many years did it take for the dwarf planets to form, or until you realized them?
Yeah, so a question about how long did it take dwarf planets to form, and maybe when we discovered the first dwarf planet. We think that dwarf planets probably formed about the same time as our planets. Actually, let me show you this. This will be one way that we can talk about that. So let's go back to Earth, get ourselves in orbit, and take a look at the solar system again. Because when I showed you guys the solar system, I showed you all the planets, and I showed you some of the dwarf planets at the edge of our solar system. But as best we can tell, our planetary system formed about 5 or 6 billion years ago. And that's when most of the planets formed. But there's also a whole lot of leftover stuff that never formed planets. So let me show you that real quick. If we do, I can work my spaceship here. Yes, there we go. So I just made my solar system a lot more colorful. Besides the planets, there's a lot of leftover debris, dust and tiny bits of rock, stuff that never became planets. Each one of these dots is an asteroid. So we know there are a lot of asteroids in the inner solar system. So that's sort of the leftover rocky debris in the inner solar system. And then we know there are asteroids out here in the outer solar system, except out here, they're much more icy. So we call this the Kuiper Belt, and this is where we find things like dwarf planets. But as best we can tell, all of this process of forming these different objects took place about 4 to 6 billion years ago. Yeah, good question.
All right, let's go to Logan.
How long would it take to get halfway across the universe at the speed of light?
Yeah, that's a good question too. So one of the things that we can do is we can talk about the scales involved. And I mentioned that a little bit. So if we wanted to turn on some things that would help us keep track of this, for instance, say 10 light years. Let's turn on a circle that's 10 light years across. We would just be, that little ring is 10 light years. So if we travel 10 years, we would just barely be to the nearest stars. If we traveled 10,000 light years, now we're on the scale of our galaxy. So let's go out even further. Let's go back to where we were and look at some of the scales involved. So if we put on some of just the nearby bright galaxies, and let's look at 100,000 light years. If we were to go out 100,000 light years, we're just barely getting beyond our own galaxy. That's that spider webby thing right there. So we'd have to get up to 1 billion light years. That's a gigalight year. And if we were looking at something 1 billion light years, if you were traveling 1 billion years at the speed of light, you'd be out to some of these nearby galaxies. But actually, these are only some of the closest galaxies. If we were to go across the known universe, we'd have to turn on some of our most distant galaxies. And here, we don't even know all of the galaxies. We've just done little surveys out in different directions. So now each of these colored dots is a distant galaxy. And here we're talking on the order of 20 billion light years to get out to the very edge of the observable universe. So I think your question was, how long would it take to go halfway across the universe? About 10 billion years. So we're moving a lot faster than that in our planetarium. Other questions?
Another question. Let's go to Alike. Sorry, Alakai.
Is there other life forms on the other universes?
That's a really good question too. So let's take a look at let's get it this way. Okay. So we're back at our solar system, and as far as we know, none of the other planets in our solar system have any life. We've looked for life on Mars. So far, we haven't found any. We don't know for sure that there's no life on any other planets, but so far we haven't found any life on any planets in our solar system. But what we're doing right now is we're actually finding more and more planets going around other stars. So I'm going to turn on, where did it go? All right, I'm going to turn on a bunch of dots. Every one of those green squares is a star in our galaxy that we know has planets going around it. We call planets going around other stars exoplanets. And every one of these green dots is a star that has an exoplanet. So we know that most of the stars in our galaxy have planets going around them. And about half of those stars probably have an Earth-like planet, a planet that's about the same size of Earth, about the right distance from its star to have liquid water. Now, we don't know that any of those are inhabited. We don't know if there's life out there, but we know there's a whole lot of planets, and that's just in our galaxy alone. So we don't know for sure if there's life out there, but we do know there's a lot of place for life to potentially be in just our galaxy. Yeah, great question.
Kayla Gabrielson.
I remember I read a book one time, and it was about a rover that they sent to Mars, and it was called Curiosity. Is that rover still on Mars today?
Yeah, it actually is. Yep. So we've sent 4 different rovers to Mars. Curiosity is our latest and biggest rover. It's actually on Mars right now. It's still traveling around. It's about the size of a car. And it's driving around, it's analyzing rocks, it's looking at the soil, it's trying to understand what Mars used to be like, if there's any water on Mars now. We actually have another rover on the way to Mars right now, and it's actually carrying with it a drone that's designed like a little helicopter to fly in the Martian atmosphere. So if that lands safely, we won't just have rovers, we'll actually have a little drone flying around on Mars as well. So, yeah.
Thank you.
Let's go to Carson.
Okay, so my question is, what will happen to all of the universes in, let's say, 10 billion years? Or what would be the guess?
Yeah, so we know that stars die. And in fact, we can go take a look at what happens when a star dies. But we also know that new stars are born. So stars over a period of about 10 billion years, a lot of stars in our galaxy would die. They'd go supernova. A lot of new ones would be born. And what I wanted to do is I wanted to show you, this is another nebula, but this is a ring nebula. When a star dies, when it reaches the end of its life and it dies, it uses up all its fuel. And if it's big enough, it goes supernova. It's this huge explosion. But even mid-sized stars like our sun, when they die, they barf off their outer atmosphere, and they leave what basically looks like a smoke bubble or a smoke ring in the sky. And that stuff, the outer atmosphere of the star, goes back out into the galaxy, and then you can recycle it and make new stars with it. So this is an ongoing process that keeps going. So over about 110 billion years or so, you'd have lots of stars die, but you'd have new stars being born as well. Well, and this actually reminds me, I wanted to show you guys one more thing before I run out of time. Last time, some of the students were asking about the size of the sun and how big the sun was, and I was looking for a demonstration to show them, and I couldn't find it, but I found it for you guys. So we looked at the solar system and where all the planets were, but we didn't get a sense of how big the planets were compared to each other and compared to the sun. So this takes all the planets in the solar system and puts them next to each other so we can see how big they are. So now we've just smushed them all together. They're not this close. But we've got Mercury, the one that looks like the moon. We've got Venus, we've got Mars, and here comes the Earth. And you can see the relative sizes of the rocky planets. Venus and Earth are the largest. They're about the same size. Mars is smaller, and then Mercury is the smallest. But then what we can do is we can actually compare the size of the inner planets to the size of the gas giants. So we can bring in Jupiter and Saturn, and then in a minute we'll add Uranus and Neptune, and we can get a sense of scale of how big the giant planets are compared to the rocky midgets. Now, the other thing that this demonstration does is it also shows the relative speed that the planets rotate. So you can see Jupiter and Saturn are spinning really fast. They orbit a lot faster, or they rotate rather on their axes a lot faster than the inner planets do. So here you can see the size of the outer planets compared to the size of the inner planets. And then we could actually add the sun as well. So, well, how big is the sun compared to the inner planets? And the sun is 99% of the mass of the solar system. We have everything that formed the sun, everything that formed the planetary system, 99% of that stuff is the sun. The planets are just the leftovers. So let's bring in the sun. There we go. And you can get a sense of the scale of the Earth and the planets compared to the size of the sun.
Thanks.
Yeah, oh, you're welcome. Yeah, I remembered somebody had asked about that in the other class and I felt bad that I couldn't find that demo. Any others? I think I've got time for one or two more.
All right. Let's go to Sophia Contreras.
What is our galaxy's biggest, brightest star?
Say that one more time. Something about the brightest star?
What is our galaxy's brightest star?
Ooh, that's a really good question. I don't know. I don't know what the brightest star in our entire galaxy is, but I can tell you what the brightest star in our sky is. Well, actually, that's kind of a trick question. Can any of you guys tell me what the brightest star in our own sky is?
The sun.
The sun, very good.
Sun.
That's the brightest star.
Sun.
Besides the sun, I'll show you guys the brightest star. Sorry. I'll point out the brightest star to you guys because you guys can find it now because I showed you how to find Orion. So I've set the sky for when Orion would be in the sky. So you need to wait until a little bit later this winter when you can see Orion in the sky. And you find the hourglass figure of Orion. He's pretty easy to find. And then you find his belt. And you draw a line down his belt to the southern sky to this star right here. And this star is called Sirius. And Sirius is the brightest star in the sky, besides the sun. So the brightest star that you can see in our dark sky at night, besides the sun, the brightest star is that in our sky is Sirius. But if we were actually to fly out into space and could look at the whole galaxy, I'm not sure if Sirius would be the brightest. Sirius is pretty bright because it's pretty close to us. A star like Betelgeuse is actually a lot bigger and brighter than Sirius, but it's a lot farther away, so it doesn't look as bright to us. But if you can find Orion, draw a line down to Sirius, that's the brightest star in the sky, and you can tell your parents, that's the brightest star in the sky, and they could say, are you joking? And then you could say, no, I'm serious, because the star's called Sirius. And they'll groan. One more question.
All right, let's go lastly to Emily Kraft.
Why is the names of the stars exactly like the same names of zodiac signs?
Oh, yeah, that's a really good question. So I guess one way to answer that is if we look at all of our constellations, let me pull these up. So our sun has a particular path through the night sky. And let's see. Over the course of the year, the sun moves through the sky on a specific path called the ecliptic. And it moves through a set of, a set of 12 constellations. So there are 12 constellations that the sun passes through over the course of the year. And it just so happens that a bunch of these constellations are animals. Someone had mentioned Leo the lion earlier. There's Leo, Cancer the crab, Gemini the twins, Taurus. So it's like a zoo in the sky. You've got all these animals. And so zoo or zoa, the word for life, like zoology, we call these constellations the zoo, the zodiac constellations. And they're the constellations that the sun passes through. So they're a special group of constellations. And a lot of the stars in our sky are part of the zodiac constellations. Good question. All right. Well, I think that's all the time I've got. I don't want to take too much of your time. I know you guys have a lot of things to do. But I wanted to thank you for letting me come into your classes and talk to you guys about the night sky and
Thank you.
do some of the planetarium.
Thank you.
You're welcome.
Hello? Can you hear it? I can hear.
Bye-bye. Thank you. Bye.
Thank you guys. Great question.
Thank you.
Bye. Have a good day.
Bye. I'm gonna leave the name. Bye. Bye. My ears. Bye.
Thanks very much, Steve.
Yep. Thanks, Rob. We'll see you later.
Yes, see you later. We really appreciated it. And yeah, thanks for doing such a great job of taking us on a trip around the galaxy.